Oh, that one lah. Okay. Right. So, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Okay, so first macam biasa test mic dulu. Okay ke tak mic-nya? Oh, by the way, dah boleh start isi attendance semua orang. Boleh isi dah, saya dah bubuh tarikh untuk hari ni. Okay, so today we are going to do lecture 2 out of 3. And then next week it will be chapter 6, and then on Wednesday it will be chapter 7. So kita akan habiskan chapter 6 next week lah kiranya. Nak masuk chapter 7 pula, which is trigonometric function. Oh, by the way, even though this chapter will not be tested in your PSPM, they will be tested in your UPS as well as your group assignment. So do make sure to pay more attention then. Kena dengar elok eh. Okay, so now nak start dah ke? Baru 22. Sekejap lah, give me a few seconds bagi saya habiskan air sekejap. Boleh tak cakap itu? Sekejap. Okay, done. Jom, start. Dia pagi-pagi ni kena minum Nescafe. Kalau tak nanti sleepy. Maklumlah, edit slide je sampai pukul berapa dah. Okay, so now let's continue from last time. So last time we have done the remainder, the factor theorem. So today we are going to proceed with the zeros of polynomial as well as some types of partial fraction. So today I'll just focusing on 2 types of partial fraction. Okay, so the learning outcome for today, you should be able to find the roots and the zeros of a polynomial. Therefore, you should be able to differentiate what are the roots, what are the zeros, and actually we do have another one which is called a factor. So you need to be able to differentiate what is a root, what is a zero, and what is a factor. And then we are going to proceed with 6.3, where we are going to construct partial fraction decomposition where the denominators is in the form a linear factor ax plus b. So we are talking about distinct linear factor. So that means we have 2 different linear or perhaps 3 different linear at the bottom or at our denominator, and then a repeated linear factor. So it might be ax plus b square in our denominator. So we will have some linear factor in our denominator. So altogether we are going to do 2 types for the partial fraction, and then we are going to learn about the root, zeros, and factor for polynomial. Okay, so let us continue with last time, zeros of the polynomial. Okay, so you should be able to differentiate what are called the zero, what is the root, what is a factor. Okay, so from the factor theorem, we know that x minus a is a factor whenever PA is equal to 0. So if we simply substitute the value of a inside the polynomial and then we get a 0, then we're going to say that x minus a is a factor of our polynomial. So what are the roots? If x minus a is the factor, then x equal to a is the root. What about the 0? The 0 is simply the value of a. So a will be the 0. So those are the differences between them. actually just the way we write them down, they actually mean almost similar thing. Hampir sama lah maksud dia kan, bila kita ganti kita tak dapat kosong. Just the way you present your answer, those will be different. So make sure you be able to differentiate between a root, a zero and a factor. Okay, so for example, a factor x minus 2 can be a factor. Meanwhile, the root will be x equal to 2. The zero will simply be the number, which is 2. So let's say they give us the zero is negative 1. Then that means in the root, x will be equal to negative 1. For the factor, it will become x plus 1. So those are the differences between them. Okay, so let us try some example then. Okay, so example 1, that is the simplest one. Show that negative 4 is a zero of 6x cubed plus 23x squared minus 5x minus 4. Okay, so what happened? We are going to call those things as px. So let us write this one down as our px. Right, so to show that negative 4 is a zero for them, I'm going to try to substitute x with negative 4. And then I'm going to prove that when I substitute x with negative 4, the answer for this one will give me 0. Okay, so substitute x with negative 4. So you are going to get p of negative 4. Oh, dah kenapa pula dah? Sekejap Rasa dia naik jadi macam tu. Tiba. Tak tahu saya nak tukar jadi power jap. Semalam okey je. Okay. Right, so we are going to substitute x with negative 4. So 6 multiplied with negative 4 cube plus 23 negative 4 square minus with 5 multiplied with negative 4 and then minus with 4. Okay, so now you can use your calculator. Calculate what is the value on the right hand side. What is this total? Okay, so basically if you use your calculator for that, you should be able to show that this is actually equal to 0. So when we try to substitute x with negative 4, we are going to get 0 on the right hand side, which simply mean that negative 4 is definitely a 0 of px. Okay, so since p of negative 4 is equal to 0, then negative 4 is a 0 of our px. So we simply try to substitute them in and then see, oh, we do get 0 at the end. Oh, so this is a 0 of px. Okay, let's go to example 2. Okay, so example 2 is quite a long question. So most of the time, the type of question will come out something like this. Okay, so factorize px equal to 2x cubed plus 4x squared minus 22x minus 24 completely and then write all the zeros. Okay, so check the power first. Okay, the highest power for this is 3. So that means if I'm looking for the zeros, I will have 3 zeros because the order for this polynomial is 3. The order is 3. The highest power for them is 3. Therefore, the number of zeros will also be 3. Okay, so now how to factorize them completely? So this is a cubic function. So of course, in order to factorize them completely, that can be quite tough. Therefore, we have to find one of them first. Okay, so for me, I'll choose to try to substitute with x equal to negative 1. So we simply choose any number that you want. So you can choose x equal to 0, you can choose x equal to plus or minus 1. Choose something that will give you a 0. Okay, so now I choose negative 1 and when I substitute into this function, I definitely going to get 0. Okay, so this method is called the try and error. Try and error lah sebab kita nak cari. But if you want to do it in a smart way, so try and error. But if you want to do it in a smart way where when you try, you're definitely going to get your answer directly. So for that, you have to use your calculator. So gunalah EQN tu, masukkan dalam calculator. Untuk kuasa 3, tengok nombor yang paling kecil masa tu. Berapa nombor yang paling kecil. So those are the first number that you're gonna try for this try and error. So when you try to substitute, you are definitely going to get 0 at the first attempt. So ni macam saja je lah, macam main-main sikit lah. Okay. But if let's say you are too lazy to use your calculator, never mind. Just try to substitute whatever number that you know. So normally people will start with the smallest number, which is 0. And then we start with 1, positive 1, and then positive 2, negative 2, positive 3, negative 3, and so on until you find out that whatever value of x that you substitute, you are going to get 0. Of course lah, kalau nak senang baik guna calculator je kan, cepat sikit. Okay, so now I know one of the 0 which is negative 1. So that means x plus 1 is actually the factor of px. So x plus 1 is actually one of the factor. So now what I can do is that I can do the long division to find the other two factor. So I will get a quadratic first and then I'll proceed with factorizing the quadratic function. Okay, so now take the polynomial and then you divide them with the factor. So 2x cubed plus 4x squared minus 22x minus with 24. We are going to do the long division with x plus 1 because I will need to have the quotient over here because the quotient is definitely a quadratic function. Sebab ini cubic bahagi dengan linear mesti dapat quadratic. Okay, so I want to know what is the quadratic so that I can factorize the quadratic. So we only learn how to factorize a quadratic function completely. So kita tak belajar macam mana nak factorize cubic completely direct je. Sebab tu kita kena buat panjang sikit lah kalau untuk cubic ataupun kuasa 4. Okay, so now let us do the long division. So think first, x multiply with what? In order to get 2x cubed, so the answer is definitely 2x squared. So we will need to multiply with 2x squared. So x multiply with 2x squared, I will get 2x cubed. 1 multiply with 2x squared, I will get 2x squared. So it will become 2x squared plus 2x squared. And then of course you have to deduct them. So x cubed, excuse me. So 2x cubed minus 2x cubed, they will become 0. And then of course 4x squared minus 2x squared, it will become 2x squared. And then simply copy down, bring down negative 22x down. So they will become 2x squared minus 22x. Next, you have to think a little bit. X multiply with what? Again, another one. X multiply with what? In order to get 2x squared. So the answer will be positive 2x. So we have to times with positive 2x. So x multiply with positive 2x, they will become 2x squared. 1 multiply with 2x, they will become positive 2x. And again, you are going to deduct them. Okay, so 2x squared minus 2x squared, those two will cancel out. Negative 22x, negative 2x, so they will become negative 24x. And then don't forget, you have to bring down that number below. So we got negative 24x, negative 24. Again, let us continue because now the power is the same. So we must continue. So x multiply with what? In order to get negative 24x. So the answer is negative 24. Okay, so x multiply with negative 24 will become negative 24x, of course. 1 multiply with negative 24, the answer will be negative 24. So we simply get the same thing. So when you deduct, you are going to get 0 as the remainder. Okay, so since we know that x plus 1 is definitely one of the factor, you should get 0 at the end as your remainder. But if let's say something happened and you couldn't get 0, most likely you have to redo your long division. Kena redo lah long division tu sebab biasanya mesti salah. Kita dah tahu ada factor, maksudnya salah satu salah. Either factor tu yang salah ataupun long division yang salah. So do check. Okay, so now let me factorize them completely. So let me write them down. Px equal to dx multiply with qx. Okay, so this is my dx, x plus 1, and then this is the q, 2x squared plus 2x minus with 24. And then for this thing, I can see that I have 2, 2, and negative 24. So that means I can easily factorize the 2. So factorize out the 2. That will give me 2x plus 1, x squared plus x minus 24. Okay, so now this thing, I'm going to factorize them completely. So 12, it can be 1, 12, 3, 4, 6, 2. So in order to get x, they will become 4 and 3. So x, x. So this is 4x, this is 3x, positive, negative. So they will become 2, x plus 1, x plus 4, x minus 3. Okay, so now bear in mind, you need to have these two. Jangan cancel out two tu. Two tu tak boleh cancel out sebab kita tak ada term yang sama dengan kosong untuk kita hilangkan dua tu. So that mean make sure to factorize them very very carefully. Biasanya kalau nak termis markah masa dekat sini. Sebab terlupa masa constant, dia mesti kena factorize ke depan. Dia tak hilang. Kalau guna calculator terus, kalau tak salah saya calculator dia akan terus bagi yang bahagian belakang. So you do miss out the two. So do make sure to check again. Once you already factorize them, make sure to expand them again and check whether do you get your top or not. Contohnya ini kalau awak expand x plus 4, x minus 3, check balik dapat sama tak dengan ni. Kalau tak sama, kena darab dengan constant lah ke depan. Okay, so this is factorized them completely, but I haven't wrote down the zeros. So the zeros for this one is negative 1, negative 4, as well as 3. So the zeros are negative 4, negative 1, and 3. So those are the zeros. So we need to factorize them completely first before we can find out what is the zeros. Okay, done with example 2. Next. Show that Px is given by the polynomial. Px is given by Px equal to x cubed plus 3x squared plus x minus 1. Show that x plus 1 is a factor of Px. So this is actually by using the factor theorem. So we just simply need to substitute them in and check that they are definitely equal to 0. So we just need to substitute. Hence, determine all the roots. Okay, so that means I have to factorize them completely and then find out what are the roots for them. Okay, so now let us show first x plus 1 is a factor of Px. So let me copy down the Px and then I will substitute with negative 1. Okay, so substitute x with negative 1. We are going to get negative 1 cubed plus 3 times negative 1 square plus negative 1, negative 1. Okay, so this is negative 1 plus 3 minus 1 minus 1. So they will become negative 3 plus 3, which will simply give us 0. Okay, so since P of negative 1 is equal to 0, that does mean that x plus 1 is definitely a factor of Px. So we know that x plus 1 is a factor of Px. Okay, so now we want to determine all the roots of Px. Therefore, I'm going to factorize them. I only have one of the factor. Therefore, I need another quadratic function or two linear function. So let me do the long division for me to get the quadratic function first, and then I'll try to factorize the quadratic function to get all the roots. Okay, so now x cubed plus 3x squared plus x minus 1, they are already in descending order. So I will divide them with x plus 1. Okay, so tinggal repeat x multiply with y in order to get x squared. So of course the answer x cubed, sorry. So x multiply with y in order to get x cubed. So the answer is x squared. Laju sangat nak bagi jawapan. Okay, x square. So x times with x square, they will become x cubed. 1 multiply with x square, they will become x square. Okay, so then you of course need to deduct them. So we got 3x square minus with x square, so they will become 2x square, and then we simply copy down the x below. So x multiply with what in order to get 2x square? So of course we need to multiply with positive 2x. Don't forget about the sign. Okay, so x multiply with 2x, 2x square. 1 multiply with 2x, they will become positive 2x. And then, of course, minus everything. So x minus with 2x, they will become negative 1. And then, of course, bring down negative 1 as well. So they will become negative x, negative 1. Right, so continue. X multiply with what in order to get negative x? Therefore, x will be multiplied with negative 1. So multiply with negative 1, we are going to get the same thing, which is negative x, negative 1. So when you deduct the same thing, they will become 0. Okay, so that means I've done the factorization in a good way because I do get 0 as the remainder. So let me write down the factor. So I will have px equal to x plus 1 multiply with x squared plus with 2x minus with 1. Okay, so now let us think a little bit. How to factorize x squared plus 2x minus 1. Okay, so now I'll give you 30 seconds. Try to factorize x squared plus 2x minus 1. What do you get when you factorize them? X squared plus 2x minus 1. Cuba factorize dapat apa? Dia tulis answer. Mana budak tutor 05? Asal seorang pun tak key in kehadiran lagi ni. Oh, ada dah. Sudah. Decimal panjang. Miss, long division ni memang sepanjang bab 6 ke guna? Ya, long division. Actually for chapter 5, when you want to sketch a reciprocal function, some of it memang kena buat long division juga. Sebab kita nak pastikan kita dapat horizontal asymptote tu. Nilai dia berapa. So kalau kata fraction, for example, x minus 1 over x plus 1 kan. Kalau nak lukis graf untuk yang macam ni, mesti kena buat long division untuk kita nampak horizontal asymptote nilai dia berapa. And then kalau masuk chapter 8 pun ada sikit kot rasanya. Dia adalah sikit. Dia macam masuk sikit. In example 4, I'll show you another way. If you don't want to do the long division, but you can actually decide whether does the long division is easier or that method is easier. Okay, so now why decimal panjang? Kenapa decimal panjang? Because basically you cannot factorize them completely by using those cross method or something you call the butterfly method or whatever you name it. Okay, so the thing is, since we cannot factorize using this cross method or whatever you see that use your calculator and you suddenly see all those decimal, that means you must factorize them by using the formula. So quadratic, basically we have two ways to factorize them. So the first one is that you can use the cross method, then you can easily get them in those bracket. The second one is that we are going to use the quadratic formula. So what is the quadratic formula? Negative b plus minus square root of b square minus 4ac over 2a. So basically, since they were asking for the root of px, so I'll go straight away with x equal to negative b then. Okay, so x equal to negative b plus minus the square root of b square minus 4ac over 2a. So the value for a over here is 1, the value for b is 2, the value for c is negative 1. Okay, so you simply substitute the value of a, b and c inside there, and then you are going to get x equal to negative 1, which come from x plus 1. Of course, the roots are x equal to negative 1. And then on the right hand side, when you use the formula, you are supposed to get negative 1 plus or minus square root of b, which means that either x equal to negative 1 plus set b or x equal to negative 1 negative set 2. Set b, set 2. So negative 1 plus set 2, negative 1 minus set 2. Okay, so those are example 4. Okay, so again, I repeat, for a quadratic function, you have two formula or two ways to factorize them. You can either use the cross method. So this one cross method. Ataupun senang cerita ni kalau guna calculator lah. Cross method, they should look like this. Another one is by using the formula, which is this one. So when you use the formula, you are supposed to get something with the set. So tinggal dalam set sebab ini irrational punya number. Okay, next. Let us go to example 4. Right, so now determine all the roots for x to the power of 4 plus x cubed minus 7x squared minus x plus 6 equal to 0. So basically the highest power of polynomial that we are going to handle is x to the power of 4. So that is actually in our syllabus. So x to the power of 4 is the highest power of the polynomial that you will work with. Okay, so determine all the roots if x plus 1 and x minus 1 are the factors of px. Okay, so now what is the polynomial? So we're gonna call x to the power of 4 plus x cubed minus 7x squared minus x plus 6 is the px. Right, so do make sure the right hand side is 0 first before you can call them as the polynomial. So kalau kata sebelah kanan tu ada x ke apa ke, tarik. Tarik, kasih kosong dulu. Lepas tu baru kita panggil dia sebagai px. Okay, so now I know that x plus 1 together with x minus 1 are the factors of my px. Therefore, I can write them down as x minus 1, x plus 1, and then I definitely need to have another quadratic function. Why quadratic function? Because this is x. X multiplied with x can give me an x square. In order to get x to the power of 4, I have to multiply with another x squared. So x squared times x squared, I will get x to the power of 4. If let's say this is a cubic function, therefore I just need another linear function. So yang sebelah belakang ni kita kena tengok lah, bila kita darab, kita nak dapat yang atas kan. So check power dia. So x times x is x squared. I need to times with another x squared in order to get x to the power of 4. Okay, so what happened next is that I will times these two together. So I will have x squared minus 1 multiply with ax squared plus bx plus c. Right, so now there are two methods to solve this. you can do the long division just like what we did in example 2 and example 3, or I'll teach you another one which is called the comparing coefficient. So we can actually compare the coefficient. So we can compare the coefficient for px. So this is our px. We are going to compare them with the coefficient when we expand this one. So we are going to try to expand this, and then I'm going to write them down in the form of A, B, and C. So in terms of A, B, and C. And then of course we are going to compare x to the power of 4, x cubed, x squared, x as well as constant. And then do find the value for A, B, and C. Okay, so let us try to expand this one first. So we are going to get x to the power of 4 plus x cubed minus 7x squared minus x plus 6. So this is your px. So when I expand this one, I will get ax to the power of 4 plus bx cubed plus c minus ax squared minus bx minus c. And then of course we can do the comparison now. So we can compare the coefficient. Okay, so the easiest one, do compare for a single one. So we got x to the power of 4 here, ax to the power of 4. So if I compare the coefficient of x to the power of 4, then that simply means that 1 is definitely equal to a. So on the left hand side, the coefficient of x to the power of 4 is 1. On the right hand side, the coefficient of x to the power of 4 is a. So when I compare them, I can easily see, so a must be equal to 1. Okay, the next one. So for me, I'll choose x cubed. So this is positive 1. This is positive b. So when you compare for x cubed, you can easily see, oh, so the coefficient of x cubed on the left is 1. The coefficient of x cubed on the right is b. Therefore, 1 must be equal to b. And then we just need to find another one, which is the c. So you can actually use x squared, or you can use the constant. So if you use the constant, then you can easily see on the left hand side we got 6. On the right hand side the constant is negative c. Therefore, the value for c is actually negative 6. Okay, so I do get the value for A, the value for B, the value for C. Therefore, let us write down the px and then substitute the value for A, B, and C. Okay, so px will become x minus 1, x plus 1, and then x squared plus x minus 6. And then, of course, we have to think a little bit how to factorize this quadratic, because you have two methods, right? So either you want to use the formula or you can factorize them completely. Okay, so this is 6. 6 can be 1, 6, 2, 3. So in order to get x, I can use 3 and 2. So this is 3x, this is 2x. So they want to become positive, so positive, negative then, so positive, negative. So I will factorize them to become x plus 3 and x minus 2. Okay, so they would be x minus 1, x plus 1, x plus 3, x minus 2. But those are the factors. They were asking for the roots. In order to write down the roots, I need to write them down in the form of x equal to what? Okay, so x equal to negative 3. So that comes from x plus 3. So x equal to negative 3. X equal to negative 1. So that actually comes from x plus 1. X equal to 1. So those comes from x minus 1. And then x equal to 2 from x minus 2. So altogether we have 4 roots. X equal to negative 3, x equal to negative 1, x equal to 1, or x equal to 2. Okay, so I think that's it for 6.2. So now we are going to continue with the partial fraction, 6.3. Okay, 6.3 partial fraction. Okay, so fraction, firstly, you should be able to differentiate what is the proper and improper fraction. So the proper fraction is whenever the degree for numerator is less than the degree of denominator. So that means at the top, this one should be less than the bottom. So yang ini adalah numerator, ini adalah denominator. So the degree for numerator need to be less than our denominator. So this one we gonna call them as the proper fraction. Contohnya kalau tengok dari segi nombor 1/2 or 2/3. Okay, so improper fraction is whenever the degree is greater than or equal to. So that means if you have something like this, then the numerator is either greater than or equal to denominator. So perhaps kalau dalam number lah kan, number dalam 3/2 or perhaps 2/2. So kalau 3/2 biasanya kita akan tukar kan. So jadi 1/2. 2/2 we are going to simplify them which is equal to 1. So that is why we're going to call them as improper. Okay, so now in polynomial, what does it mean by a proper fraction? So they will have something like 3/5x. So this is x to the power of 1. At the top, this is x to the power of 0. So the degree is definitely less than our denominator. So this is a proper fraction. Okay, look at the second one. We got x squared. At the bottom, we have x cubed. So this is 2, this is 3. So at the top is lower than the bottom. So this is definitely a proper fraction. This is the same thing. X squared, x cubed. So the degree for the top is lower than the denominator. So this is also a proper fraction. Improper. So this is x to the power of 0. This is also x to the power of 0. So they do have an equal power. So they are not proper. So this is improper fraction. Okay, so this one, the highest power is 4. The highest power is 3. So this is the degree for numerator is greater than the denominator. So this is also improper fraction. Okay, so the third one or the last one, this is x cubed over x cubed. So we got the same power for the numerator and denominator. So this is also called improper fraction. Okay, so those are the types of fraction. Okay, so why do we need to be very particular? Are we looking at proper or are we looking at improper fraction? Because the method is slightly different. For payahlah dia banyak sangat F. For proper fraction, proper fraction, you can directly do the partial fraction. So you can directly do the partial fraction if you have them in a proper fraction. But if you have an improper fraction, what you need to do is a long division first. So you need to do the long division and then you need to take the remainder over with the divisor. So those proper fraction, we are going to do the partial fraction for it. Okay, so improper fraction, when you do the long division, you are going to get something like px over dx equal to, oops, tak nampak beza dah pula d dengan p ni, sabar je lah. Okay, so this is qx plus rx over dx, remainder over divisor. So if you have improper fraction, then after long division, you are going to take this one and then you are going to do partial fraction for that fraction. If you have a proper fraction, then you can directly do the partial fraction. Okay, so for partial fraction, you need to check your denominator. You need to check whether do you have a linear factor or a quadratic factor in your denominator. If you have a linear factor, do check, are they distinct or are they repeated? Distinct, that means different. So you might have something like x minus 1 and x plus 1 in your denominator. So they are distinct linear, two different linear factor. repeated linear, they might be something like x squared. So we do repeat x multiply with x. So, or perhaps something like x plus 1 square. So we do repeat x plus 1, x plus 1. So they will become a square. And in fact, we can have x plus 1 cube or x cube as well. So depending on the question. So we might repeat up until cube. If you have a quadratic in your denominator, you need to check first. Can you factorize your quadratic function? If you can factorize them, then they will either become the repeated linear or a distinct linear. So we are going to handle it like a linear factor. But if you have a quadratic factor that cannot be factorized, then this is actually type 3 for partial fraction. Okay, so now linear factor, check first. Are they distinct linear? If they are distinct, then this is type 1 for the partial fraction. If they are repeated linear, then this is type 2 for the partial fraction. If you have a quadratic in your denominator, you need to check, can you factorize them or can't you factorize them? If you can factorize them, then you have to check, are they distinct? Are they repeated? You must check. If they cannot be factorized, then that is simply the third type of partial fraction. So we are going to cover that next week for the third type. So today we are just simply going to do the first and the second type. Okay, so now how to do the partial fraction. Okay, so this is basically how to change it into fraction. Okay, so partial fraction, we actually decompose it into a sum of the the factor in our denominator. So for example, over here, this is x minus 1, x plus 1. So we are going to separate them where one of the fraction, I have x plus 1 in the denominator. Another one, I have x plus 2, x plus 1. Katalah x minus 1 kat sini, x plus 1 kat sini. Asal nombor dia tak sama, suka hati je. Okay, tak apa. Right, so for example, x minus 1, x plus 1, so those are linear factor. So we will separate them into two. The first one is something over x minus 1. The second one is something over x plus 1. Okay, so basically, if you have a linear, then that means at the top, this is a constant. So now our job is to actually find out what is the value for A and B. So you might be wondering, this is quite long, right? Because we want to find out what is the value for A and B later on. Where do we use this? You are going to use this more when you learn integration, because we have something called integration by decomposition into partial fraction. Integration is a topic for the second semester, the first topic actually. So you need to know how to decompose it into partial fraction. Okay, so if you have a quadratic factor, right? Okay, so this is a linear. This is a quadratic that cannot be factorized. So when I separate them, I'm going to separate them with x and then another factor over here. So x squared plus x plus 1. Okay, so since x is a linear, therefore I should have a constant at the top. So this one is a quadratic that cannot be factorized. Therefore, I will use a linear at the top of them. Repeated linear, for example, 1 over x minus 1 square. So what happened is that when I decompose it, firstly, I should write them down in the lowest power, which is x minus 1 to the power of 1. And then we keep going up until we reach our linear factor, repeated linear factor. Okay, so now this is x minus 1 to the power of 1. This is x minus 1 to the power of 2. Okay, so this is linear. This is just a repeated linear. Therefore, we are going to use a constant for them. Okay, so now if you look at the last one, this is a linear. This is repeated linear. Okay, so when we separate them, so we separate for x first, and then for x minus 1, they are repeated. So firstly, we have to write down x minus 1 to the power of 1, and then x minus 1 to the power of 2. If you have cube, then you have to proceed until x minus 1 cube then. And then everything is simply a linear or repeated linear. So at the top, they are always a constant. Okay, so basically we only use a quadratic whenever the quadratic cannot be we only use a linear at the top when it is a quadratic that cannot be factorized. So kalau dia adalah quadratic yang tak boleh factorize, baru atas ni kita letak linear. If they are distinct linear or even repeated linear, we are simply going to use a constant at the top of it. Okay, so now let us focus on the example then. I think we are going to understand more if we look at the example. Okay, so this is the first type denominator with distinct linear factor. Okay, so look at your linear factor over here. So we have x minus 4, x plus 6. And I do see that they are different from each other. So this is what we call as the distinct linear factor. Okay, so when you separate the fraction, you are going to get x minus 4, x plus 6. Since they are simply a linear factor, so we are going to write down some constant a and b. So our job right now is to actually calculate what is the value for a and b. Okay, the second one, again, we have x plus 3, x minus 5. Both of them are actually linear and they are different from each other. Therefore, when we separate them, this is x plus 3, this is x minus 5. And then, of course, we simply use a constant on top of them. So a over x plus 3, b over x minus 5. And then you just need to find out what is the value for a and b. Banyak juga lah. Factor lah, fraction lah, macam-macam, partial. Dia P dengan F tu payah sikit kalau nak sebut. Okay, now express 2x minus 3 over x plus 1, 3x plus 2 as partial fractions. Okay, so now we need to write down the correct format for them first. So check your denominator. Okay, so this is x plus 1. This is 3x plus 2. So they are linear factor and they are not repeated linear. So this is a distinct linear factor. Okay, so distinct linear factor, you must separate your denominator and then at the top, we are going to use some constant. Okay, so separate your denominator. So you will have x plus 1, 3x plus 2, since both of them are actually linear. So we can use a constant at the top. So a, b. Okay, so this is separate the denominator. So you must separate your denominator. What happened next is the method in order to find out the value for a and b. So on the left hand side, I have a single fraction, but on the right hand side, since I separate the denominator, I have two fractions. So let us have a common denominator on the right hand side. Okay, so I simply need to have a common denominator. So A will be times with 3x plus 2. B will be times with x plus 1. So this is a common denominator. Okay, so now, since I have a common denominator, so I actually have the same denominator on the left and on the right hand side. What can we do is that we can easily compare our numerator. So we can actually compare at the top. They must be equal because the bottom are equal. So the top must be equal as well. So we must do the equivalent of our numerator. So 2x minus 3 is equal to A, 3x plus 2 plus B, x plus 1. So that is the third step. So the first step, you must separate your denominator. The second step, you need to make sure you have a common denominator. The third step, you must have an equivalent numerator. The fourth step is the solving part. Right, so for solving, we actually have two different methods for them. So you can choose anything that you like. So saya ada dua method lah kiranya. Something that is much more comfortable with you, up to you. It doesn't really matter. Either one will work just fine. But for me, I'll say just learn both because sometimes substitution is easier. Sometimes comparing coefficient is easier. So for this question and the next question, I simply do both of them so that we can easily compare what method to use. Okay, so the first method is the substitution. Okay, so in substitution method, we are going to try to substitute what is the value of x so that these factor are 0. So I'm going to try to substitute with some value of x that will give me 0 for the factor y. Because if let's say I substitute x with -1, then this one will become -1 plus 1. So they will become 0. 0 times b, they will become 0. So I simply left with one of them, which is a. So that is the easiest one to do substitution. Okay, so for me, I'll choose something that will give me a 0 for the factor. So the first one, I'm choosing -1. So I will have 2 times -1 on the left, minus 3 equal to a, -3 plus 2. So this is -1 times a, this is -5. So a times -1 is equal to -5, which means that a is definitely equal to 5. Kiranya pecahkan denominator, lepas tu sambung balik. Boleh lah kalau nak cakap macam tu. Pecahkan denominator, lepas tu sambung balik. Tapi kali ni kita nak tahu nilai A dengan B. Sebab bila kita tahu nilai A dengan B, baru kita boleh salin balik yang first ni dengan pecahan. Siap-siap. Maksudnya kita dah pecahkan nilai A apa, nilai B apa. Okay, so now I substitute with -1. I have the value for A, which is 5. And then the second one, I substitute with -2/3. Just in case you couldn't see why I substitute with -2/3. That is because if I substitute the x over here with -2/3, A will be times with 0. So that is my aim. Okay, so after I do that, I can see that the value for B is actually equal to -13. So I do get the value for A and B directly by substitution. So when I substitute, I make sure the factor is 0. Then whatever variable they are multiplied with, those will become 0. So I only left with one of them. Okay, so now the easiest one is to try to find something that will give you 0. But if let's say you couldn't find something that will give you 0, then you can try to substitute with any number that you know. So dia tak semestinya kena ganti nilai yang dapat kosong. Yang ini nilai yang cepat lah. Sebab bila kita ganti nombor yang boleh membuatkan faktor tu kosong, dia cepat sikit kita darabkan kosong kan. Tapi katakanlah kan, tiba-tiba je rasa macam hilang ingatan macam mana nak cari nilai x ke apa ke kan. You can actually substitute any value of x that you want. The only problem is you will have to solve the simultaneous equation. So that's the only problem. You can actually substitute with any value of x. The only problem is that you need to solve the simultaneous equation. Tu je lah. Tapi macam saya katalah, bila kita dah ganti nilai yang memang faktor dia tu kosong, then tak perlu solve simultaneous lah. Terus dah dapat jawapan. Okay, so that is the first one, which is substitution. The second one is something called the comparing coefficient. So for comparing coefficient, you need to expand the right hand side and then you are going to compare them with the left hand side. Okay, so let's see what happens if I expand the right hand side. Okay, so when I expand the right hand side, I will have 2x minus 3 equal to 3x plus b, x plus 2a plus with b. Okay, so what happened next is that I will compare x on the left, x on the right, constant on the left, constant on the right hand side. So when we compare them, we should be able to see that 2 is equal to 3a plus b, and then -3 is equal to 2a plus b. And then solve them simultaneously, solve simultaneous equation. Then you are going to get the same answer or the same value for A and B. They will be similar, just depending on whether it will take longer or not. Okay, so now A is 5, B is -3. You shouldn't stop over there. You should go back to the first one where you separate the denominator. Copy them again, but this time substitute the value for A and substitute the value of B. Okay, so 2x minus 3 over x plus 1, 3x plus 2 is equal to 5 over x plus 1 minus 13 over 3x plus 2. So now I already have them in a different fraction. So I already separate the denominator into 2 now. Okay, so dah pecah dah lah. So okay, partial fraction dah. So yang ini boleh integrate dengan senang lah kiranya kalau nak buat integration nanti. Okay, done. Example 6 now. Oh, example 6, I left that as your exercise. Lupa pula. Kita proceed kepada example 7 lah sebab banyak sangat sebenarnya. Example tak ada nak buat semua. Okay, so let us proceed with the second type where we have a repeated linear factor. Okay, so this is a linear factor, but this is a repeated linear factor. So when you separate your denominator, one of them will become x minus 3. And then for the repeated, we will have x plus 5 to the power of 1. And then another one is x plus 5 square. Okay, the second one over here, in your denominator, you have x square and then 3x plus 5. So we are going to have x first, x to the power of 1. And then x square. So those are repeated. And then another linear is 3x plus 5. Okay, so basically everything is a linear factor, right? So even though it is a repeated, they are still linear, just repeated linear. So you just use a constant at the top. A word of caution for type 2, you must be very careful when you want to have a common denominator. So I'll show you how or what is the easiest one, the easiest method to know how to do the common denominator. Okay, so I'll show you later on. Okay, so now try to express 7x over x plus 2 square in partial fraction. Okay, so we only have a simple thing which is x plus 2 square in our denominator. So this is a repeated linear. So make sure you have x plus 2 to the power of 1 first and then x plus 2 square in your denominator. Okay, so firstly we have x plus 2 and then x plus 2 square. So this is a repeated linear. So this is where you separate your denominator. Okay, so what is the second step? The second step is where we want to have a common denominator. Okay, so my advice is that you take this denominator on the left hand side and then you divide with your denominator. Whatever left, you times them with your constant up here. Okay, so for example, x plus 2 square, you divide them with x plus 2. So when you divide them, you are going to get x plus 2. So that means A will be times with x plus 2. Okay, meanwhile for the B, we have x plus 2 square over x plus 2 square. So when we divide them, we are going to get 1. So therefore, B is simply multiply with 1. Okay, so make sure you have a common denominator. So A will be times with x plus 2 and then B is simply B because we do B times 1 over x plus 2 square. Okay, so this method will be very useful especially when you don't have two fraction only. If let's say you have 4 to 5 fraction, so this method will be very useful. Sebab bila lama-lama kita akan start pening dah tau. Kita nak darab dengan apa. Sebab kalau step common denominator ni salah, memang sampai bawah semua akan salah. So memang kena hati-hati when you separate your denominator, the first step should be correct first. This step you must make sure they are correct. Kalau first step dah salah, memang sampai bawah kita tak akan tengok dan terus markah kosong Alert semua orang. When you separate your denominator, they must be correct. They must be in the correct format or the correct form. So that means if you have a repeated linear, they should look like this. If you have a distinct linear, they should look like the previous one. So you must separate them in a correct way. So separate the denominator, this one must be correct first. If you get this one wrong, everything else is wrong. And then to make sure you have a common denominator, check extra careful, hati-hati masa sama kat bawah tu. Kalau perlu bahagi lagi sekali, dapat sama tak dengan atas. Okay, so I already have a common denominator. So what happened next is that I just compare my numerator, so equivalent the numerator. And then of course we come to the fourth step, which is the solving part. So again, we have two methods, either substitution or by comparing coefficient. Okay, so I'm using substitution now. So I will try to substitute with -2. So 7 times -2 is equal to B. So that means B is equal to -14. Okay, so basically for this part over here, I don't see any other factor. So better for me to use anything, any number that I want. So I choose X equal to 0, I think. So I choose X equal to 0. So I will have 7 times with 0 equal to A times with 2 and then plus with B. So -14 over here. So that means that A is definitely equal to 7. So from here, I know the value for A, I know the value of B. So I can actually go back here and then substitute the value of A and B. Okay, or you might want to use another method which is called the comparing coefficient. So how to compare the coefficient? Okay, so 7x is actually ax plus 2a plus b. So when you compare coefficient, you should be able to see that 7 is equal to a. So we compare the coefficient of x. And when you compare the coefficient for the constant, then 0 is equal to 2a plus b, which means that A is 7, B is -14. So for this solving part, you can choose either one. So either you are using the substitution or you can use comparing coefficient. Choose either one. Janganlah buat dua-dua, semak nanti. Choose either one. Okay, so once you have the answer or the value for A and B, go back to the first step where you separate your denominator and write down the value for A and B. Therefore, the final answer for this is 7 over x plus 2 minus with 14 over x plus 2 square. So that is your partial fraction. And then you can easily do the integration part now. Bolehlah nak pakai formula dengan senangnya. Okay, so of course, example 7 will be your exercise as well. So that's it. So I'll see you guys later untuk tutorial. So nanti tutorial saya akan bagi briefing lah untuk group assignment sebab saya dah bagi group assignment kan. So I'll do some briefing on the group assignment. So I'll see you guys next week. Bye bye. Untuk kuliah lah. I'll see you guys next week. Bye bye. So tunggulah link Google Meet saya. Okay, bye bye eh. Jangan lupa isi tandem.